So remember that when you multiply a vector by lambda, where lambda is any scalar, that will enlarge it by the enlarges that vector, the magnitude of that vector by a factor of lambda. So for example, if you just have a vector A and you want to double its length, you can multiply it by 2 in order to double its length. So 2A will have twice the magnitude of A. Similarly, if you want to shrink it, you can also multiply it by sort of like a fraction in order to sort of shorten its magnitude. For example, if we want to halve A, we can just multiply it with half. And two vectors are parallel if they are scalar multiples of each other. So if B equals K times A, where K is a real number, then B is parallel to A. Because all of these vectors here are scalar multiples. And therefore they're all parallel because we can express each one as K times A, where K is just some real number. So this is question 2 from the sample NESA Extension 1 paper. So we have a grid of equally spaced lines. The vector OH is H. So this vector we said is H. And the vector OA is A, like that. So we're asked which expression represents the vector OP. So we want to get this vector OP here. So to do that, we have to add OA to AP. So we know that OP is what we get when we add OA with AP. Now here's the thing, we know that OA is already the vector A, but here this AC is the same thing as OH. They're both H because they're the same direction and the same length. However, AP is not the same length as OH. It's actually going to be, so if we split these into quarters, it's actually 3/4 of the length of AC. So AP is actually going to be 3/4H. So therefore, that will give us a D as our answer. So you just want to, so that assesses our knowledge of vector addition and also multiplying vectors by scalars.